Our code runs with a throwaway driver called main, hard-coded with a single set of parameters. This would be replaced by the GUI in an actual system. Our radio class simply converts the actual radial and good-bad signal indicator into a single parameter, the radio input. Our primary class is a VOR system with methods for computation and output. Signal validate recognizes if the signal is good or bad. The deflection calc method first calls signal validate, then calculates the difference between OBS and actual radial. If a bad signal is received or if the plane is abeam the station, the bad indicator will be set. The direction method sets left or right deflection. The to from sets the to from flag, and dot calc determines the number of dots or full deflection. Lastly, the output method is responsible for calling the above methods and outputting the various settings as a string, or simply returning bad if either a bad signal or an abeam situation exist. To validate our output, we created two test classes with JUnit. The first, called driver test, performed unit testing. We made methods public to test them individually and used assertions to check that variables were set correctly. We first tested the radio class because its output is being passed to our VOR system. Tests were divided by class and by method. We tested each branch of each if-else clause, including corner cases. In this way, we individually validated every branch of our flow control. For the second set, we wanted to test the entire system using a representative sample of inputs and output. We developed 17 test cases and somewhat randomized the OBS and actual radial for each. If the purple line were the OBS in each case, actual radial for the testing would look like this. Here we hit each of the 4 quadrants at full needle deflection, full forward, full back, and each of the 4 number of dot situations. We also tested a bad signal, 2 different abeam situations, and for good measure, each of the situations where the output would be 0 dots left or right. The class VOR quadrants system test implemented each of these test cases using JUnit as before to validate. JUnit confirms that all tests check out in both unit and system testing. Our radio and VOR system classes are correct. Team Dunbar provided 2 classes for their final submission, GUI and driver. Driver randomizes the actual radial of the radio input received. They removed this feature for testing, and so will we. But looking at the unedited program, several problems are apparent. They chose to implement a GUI which was not required and may actually contradict the requirements. In the code for the classes, there does not appear to be any way to send a bad signal, no good-bad indicator, and no to-from flag. From that alone, this program would fail any system test. Lastly, the needle moves much slower than expected. While the dots should each indicate a 2-degree difference, it takes far more than that for the needle to move to the next dot. Rewriting the code, we're able to control the actual radial, setting it to due north. It takes a 30-degree difference to reach the first dot, 15 more for 2 dots, 15 again, and a 90-degree difference before full deflection is reached. Here, we should also see a bad output because we are at the abeam situation, but the output has not changed. At 170 degrees difference, we should see the needle begin to shift gradually, but instead, we see the needle suddenly jump full right to full left. The other half of the dial mirrors all of the problems we have seen before. The biggest challenge Team Fisher faced was in correctly interpreting the requirements, and we refined our understanding throughout the first 3 team assignments. For the second assignment, there was some miscommunication about how to structure our code, but we were able to resolve that for the final version. For the third assignment, we improved our code to better conform to object-oriented style. We also reviewed the requirements and output, and added proper deflection calculation for a difference of 170 to 190 degrees between actual radial and OBS, which we hadn't accounted for previously. Ultimately, our project was a success. We were both satisfied with the code and output, which we verified in 2 sets of testing.